Hello.
Was that somebody
Hello.
volunteering to take notes?
I was going to ask, yes.
I think, Andrew, you've just volunteered. Is that right?
Sure. I just joined.
No, don't feel any pressure. Just joking.
Right on. Nice to meet you guys.
All right. Well, until somebody else volunteers to take notes, I will do the best I can to kind of keep up with it in the background. Please feel free to jump in and help us out, though. The link is the little page and pen icon right up the top of the screen, and it takes you over to Hedgehog. With
I
that,
can also write a few notes, Justin, if I'm not talking. So that's fine.
that would be greatly appreciated. Thank you, Hannes. All right. With that, let's go ahead and kick this thing off. Let me see. So I'll try to get this here. There's it. So I'll jump on screen and say hello, everybody. Welcome to the WIMSE interim meeting, January 2025. The topic is going to be the WIMSE architecture document. This is an official meeting of the IETF, which means that all contributions are covered by the IETF note well. So it is on screen. Please note it well. And pretty much it just means that anything that you say today is taken as a contribution to the IETF. There's a lot of other details of that if you're interested in learning more. There's lots of stuff on the IETF website about this detail. Do also note that unless you are actively speaking, that is, you are in the, you have been acknowledged to be in the mic queue, or you are presenting, please keep your camera and video off. The chairs might jump in from time to time to actually, help facilitate things, but we will largely be here in the background as well. Yeah, welcome to WIMSE. Peter, do you want to do this next bit? We didn't rehearse anything. So.
Sure. Do I have control? So, or can you forward the slide? Okay. So, welcome everybody to the WIMSE interim meeting. Maybe next slide. So our agenda for today, quick welcome by the chairs, and then Joe will take us through the latest architecture draft and have some questions for discussion. And next slide, please, Justin. So just a reminder, some of the working group resources. If you haven't joined the mailing list, please do. We have a great website that is nice and easy to navigate, and also the GitHub pages. And then next slide, just a reminder, some current working group documents. There is the WIMSE architecture doc, service-to-service authentication, as well as the renamed workload identity practices following the previous meeting in Dublin. So for folks who are interested, please do review these, start filing issues, and let's keep moving them forwards. And thank you to the editors who have been actively evolving these documents as well. Next slide, please. Right, I think that is it.
Yeah.
Please continue to be active participants, and also we would continue to encourage folks. Right, I know there's a lot of work around the token exchange side of things, for example, or a lot of discussions. Please please feel free to contribute drafts and bring them to the working group for consideration. It'd be great to see some additional proposals coming up for the IETF meeting in Bangkok, IETF 122. Thank you, everybody. And Joe, I'm going to hand over to you at this point.
Yep. Also, just note, everybody, this meeting is being recorded. So for people that aren't able to make the time today, we'll be able to review all of that stuff. So please keep that in mind. All right.
Okay, I'm trying. Excuse me.
Yeah, I'm giving you permission when it pops up on my side.
But it's not giving me a choice of slides. Is that the usual thing, or?
No, you should be given a choice of slides.
Now I see it. Now I see it.
Okay.
So
Either pick. I uploaded the updated version. So if you pick WIMSE Architecture Revision 01, that should be the correct deck.
all right, we'll give that a try. Thank you. Good morning, afternoon, evening, whatever time it happens to be where you are today. I'm Joe Salloway. I'm here with Hannes and Yaroslav to chat about updates to the WIMSE architecture draft. Let's see. So a little bit has happened since the last draft. We added some new content, and we'd love to discuss that with you today and get your feedback on it. So we'll go through that, and then which is this scenarios section, and then we'll talk a little bit about attestation. Hannes has some thoughts there, and then we'll also hopefully have some time for open discussion. Although, if we have good discussion in other parts of the session, that's fine. If we run out, we can always take this discussion into GitHub, onto the list, or other forums. Next page is, so one thing we want to do is thank a bunch of folks who have been giving us comments and contributions of texts and having discussions with us. A few of them are listed here. There are many more who have kind of contributed in different ways to this effort. We really appreciate it. And perhaps not all of the issues and text have been resolved yet, but that's because this is an ongoing draft, and we'll be working through these. Next. Okay. So what did we actually do since the last time we published this draft? Most of it, I believe there may be some textual changes to some terminology, but the main thing that we did, the bulk of the new work, is in the scenarios. We added a section called scenarios, which kind of goes through what we think are some very common interactions within a workload environment, and that we think will bring out some of the things that we're working on in the other groups, like service-to-service authentication and token exchange and translation, right? These are things that, like, pieces that fit into the architecture. We're trying to see how they fit and understand what the different roles are and how they interact. Okay. And I don't know, we published this draft only like a week or two ago. I meant to publish it earlier, and then I forgot. It wouldn't have been that much earlier, maybe a week earlier. And I forgot I had to do the submission button as well as go through the publication process. So I forgot that last step. And so it took an extra couple days. And I know some reviews came in before the draft was actually posted. So unfortunately, that was a little bit of my error. And hopefully we'll get that. Hopefully, everybody's had a chance to look at it. If not, we'll go through some of the new stuff now. Whoops, I'm going to go one too many. Okay. So, and feel free to stop me at any time, so I don't ramble on too long if you have questions. So this is kind of what a scenario looks like. It shows a basic kind of component architecture diagram that shows, an application. And so we have an application client that's talking to our application, which is represented within a trust boundary. Okay. And so in this particular case, we've kind of identified a first step in here, which is kind of internal to the workload environment, which is how the workloads themselves get their credentials, right? And this is, could be through some CA or credential service, and we aren't going into the details at this point of each of these types of protocol interactions, but merely talking about what the function of those protocol interactions would be and kind of their rough ordering. Once the kind of that internal environment is set up, and internal is a word that I'm using, this is really within a particular trust domain. And so there could be multiple trust domains that make up this application, and they all need to be kind of set up in a similar way. Internal and external is what I'm using here as an identification for what's in the application and what's outside the application. Your system that you envision might be more complex, and internal and external might not have any meaning, or there might have different meanings, or you might have additional trust domains that you'd be concerned with. But trying to keep things a little bit simpler, just kind of identifying it in this way, I think is helpful. It's kind of a classic way to do it, but may not be mapped to all of the architectures that we might be thinking of. And that's something we could look to address in the future. Fleming.
Hey, Joe. So first of all, appreciate the updates. And I think the addition of these different scenarios, I think that's definitely helpful. I think this diagram might be a good place to bring up an issue that I've mentioned before, which is when you come up with a definition of what your workload is, I think we still say that it's just a single running instance. And looking at this diagram, right, it's a little bit unclear when you go through some of the scenario text as well, right? Workload 1 and 2, they could be either completely different services, if you will, or they could be two instances of effectively the same service. I think for the latter scenario, I think we need to agree upon upfront, how do we deal with that? Do we want to have the ability to basically say there is actually a single identity associated with two different instances of what constitutes the same service? Maybe in addition to each of those workloads also having a separate identity, or do we not? Because I think that sets the foundation for a number of different things in terms of what kind of identity information do we need to carry going forward. Like, I don't think necessarily that I always care that this is instance 1, 2, or 3 of a particular service, but I do care that it's service A, because that's really what I'm going to be doing my access control decision based on.
Right. So just to kind of rephrase a little bit or go over, it's, we can have two instances. Workload 1 and workload 2 could be both the same software and two different instances of that software running. And in which case, like for authorization purposes, perhaps we don't care which one it is. We just, we want to connect to, we want our traffic to go to workload 1 or workload 2, doesn't matter, they're equivalent. There could be cases, for example, if we're trying to audit something that happened in the past, where it may matter that we know exactly which instance of something was executing at that time, for whatever reason. Exactly. I think that I've been kind of thinking this as like, there's an authorization identity, which is kind of maybe the main identity. Well, I won't say there's an authorization identity, which is kind of, there could be many instances of that same authorization identity. And we have an instance identity that would typically represent a single instance of that software running. I think that would probably be good to, I agree that that's probably a good distinction to make. And thanks for clarifying that, because that for me makes some of your other comments on how we talk about identity a little bit clearer as well. So okay. I don't know if anybody else has any thoughts on that whole particular item, but it's something to, I think it's worthwhile to bring up. Mark?
Hi, so I am joining this working group because I have a strong interest in confidential computing, and I work with the Confidential Computing Consortium. And I think specifically this should be addressed as in a way that will be made compatible with confidential computing. So specifically with confidential computing, one can attest both the client and the server of a communication, and then basically see if the measurements of the workload are the ones that are permitted per policy. Now, of course, in real-world scenarios, you will rarely be talking to the instance of the workload directly. You will be going through a gateway, and this is something that in the Confidential Computing Consortium we will have to figure out, and there's some work underway. But I think the case where Workload 1 is in fact a different software than Workload 2, which could be simply because different URLs are handed to different processing instances that are just doing different things, or it could be that Workload 2 is an upgraded version of Workload 1 and we haven't fully failed over to or upgraded over to the new version. So I think what needs to happen is precisely that. When an app client talks to a gateway service, and I second that, it's really talking to an entirety of the service for the standpoint of this client, and it need not know and should not know, the machinations behind the curtain. And at the same time, it needs to do it in a way that does not compromise the security goals. So, for instance, for confidential computing, if your CSP, your hosting environment, is outside of your trust boundary, so you must continue protecting data in transit and at rest after it hits the gateway service. And so, for instance, you may terminate the TLS at the gateway service, but then the gateway service needs to be able to convince the workload that it is talking to specifically the app client, not just the just that it has the right credentials, but in some cases also that it is running the right version of the software. So anyway, I'm not offering solutions here, but I'm saying if we solve this for confidential computing, we solve this for all, while also being backwards compatible with today's non-confidential software.
Okay, thanks. Yeah, so I think what you're saying is like confidential computing was kind of dealing with that identity of the software problem, and maybe there's something there we can leverage in terms of doing that. And I think, and certainly one of the things we're looking at here is the identity of the workloads as they talk to one another, which would kind of be within that confidential computing.
Right, and in this case, the identity both of the client and the workload are relevant.
Great. Your own.
Yeah, 2 points, I guess. I think it would be more consistent and more realistic to talk about WIMSE identity or WIMSE identifiers at one level and not try to define different levels of identity like cluster identity versus instance identity and all the complexity and frankly philosophical discussions that come with them. I think it's better to define one level of identity or one level of identifiers and describe exactly what the properties are. And then, in my humble opinion, we should not let confidential computing define the WIMSE architecture. Confidential computing is complicated, and it's only one use case of WIMSE, and there's tons of complexity with CC identity that we simply don't want to dive into here. Just one example, I might have a cluster of the same software running 3 times, and then I upgrade the version of one of them, but it's still the same cluster. I just haven't updated the other 2. I think that's still one WIMSE identity, but it's clearly something that confidential computing cares about. I just don't want to dive into that in WIMSE. Thank you.
Yeah, thanks. I think that's certainly a good thing to take into consideration. I mean, I think if for nothing else, like we may define, I mean, we would define what WIMSE identity is. We should also define what it isn't. And I think that's kind of Fleming's point is like, we don't really do that right now, and we should, right? So that we kind of can eliminate some of that confusion. Yaroslav.
Right. Hopefully without going too deep into rat hole, first of all, I think in addition to identifier, we have also context that we could leverage to signal additional properties if they're relevant, such as attestation. But one other thing I wanted to say, Mark, if there are some specific conflicts between confidential computing and WIMSE architecture, I think it would be really good if you could raise those as GitHub issues so that we could track them and rectify them if it's possible without creating an overwhelming amount of complexity.
Absolutely. I certainly do not want to rat hole today's discussion. I will, however, say, so I can have the last word on this, Fleming, but I hear what you're saying. Also, what you said also, I think, betrays sort of perhaps an incomplete understanding of how confidential computing identity is going to manifest. But if you read today's confidential computing documentation, you are completely right. This is the conclusion you'd come to. So I sent you a LinkedIn request. I will discuss this with you offline.
You're muted, Peter.
So Joe, one comment generally, I think we should be careful about using terms like WIMSE identity or just the identity term in general. I think if we are referring to the use of a credential, right? I'm presenting my JOT, my certificate. Let's refer to not presenting my identity, but present my credential. Be clear about talking about identifier. It's a very convenient shortcut to talk about the identity, right? This is the WIMSE identity, but that leaves so much scope for interpretation, right? I would sort of encourage folks to just think more about the actual thing, the actual artifact that's being used and presented, because the identity concept itself is, it's almost undefinable. And so I'd rather encourage folks to think about like identifiers, credentials, attestation, right? The specific aspects of managing and setting up that identity to just avoid that trap of trying to define what identity is in general.
Thank you. I appreciate that. That's good feedback.
Peter, for the notes, were those comments with the chair hat on or off?
That's a chair hatless comment.
Excellent.
No hat was worn. No chair hat was worn.
All right, thanks.
All right, just to kind of continue out throughout this scenario, I think probably it's somewhat self-explanatory, but the different workloads here, the gateway receives the request, forwards it on to the correct workload. There's probably some authentication that happens here, and then these workloads communicate with one another. And there's certainly service-to-service authentication, which is the topic of another work item that happens between here using WIMSE credentials and WIMSE identifiers, right? So I think this is a relatively simple scenario, but there's, this brings out and I think has helped to clarify, gives us things to discuss that are a little bit more concrete than what we've been doing in the past, where there's been a bunch of words or things that haven't really been targeted at like what an application might look like. So I think I'm going to go on to the next one, which kind of brings context in, but if anybody has any final words here, but I think we've talked about a lot of these things. Going once, and move to the next scenario, which talks about context, which now is going to bring up another consideration in here, and I think Yaroslav alluded to this. So now we kind of skip some of the things that maybe we took for granted, that we illustrated in the previous one, such as the bootstrapping of the identifiers and credentials into the workloads. And now what we're looking at is when a request comes into an application, the first thing that typically happens at some point, maybe previous to that request being made, is some authentication happens. This authentication may, in many cases, take the form of something like an OAuth, Open ID Connect sort of interaction that authenticates a user, or there could be other things, mutual TLS, or all sorts of different authentication mechanisms. But they'll typically result in some kind of access token being issued to the client. And certainly people could take issue with my terminology, and we can help fix my terminology. But in any case, the application will have a token that it can use. And in this case, I believe that token is probably an access token that it's using to make a request to this application. Now a common pattern within a lot of applications is that when this token is processed, the gateway or some similar service will contact what I'll call here a context service. Could be a token service, could be called an authentication service in some systems, but basically some service that's going to take in that access token, evaluate it, validate it, and perform some calculations to figure out, okay, who is the user that's accessing, maybe what tenant they belong to, maybe some things about groups, or like any kind of, all sorts of information that they may have about that request coming in, and they will generate a context token. And this could be, say, in the form of a transaction token. So transaction token, for those who may not be familiar, within the OAuth working group right now, they have a very interesting work item called transaction tokens, which is essentially similar, if not the same pattern as this, where a request comes in, and that access token is exchanged for a transaction token, which is a token that's for internal use, that has the scope and the information, that authorization context or security context that's relevant to the internal application. So now when that gateway service is forwarding requests from that client, these requests will, instead of having an access token on them, they will have this context token that then the workloads will use to perform authorization and perhaps other functions, and perhaps maybe even there could be steps to augment this token as it goes through the network. But this is, if you're familiar with the transaction token case, this is essentially that, I believe. The lines aren't, I didn't do it maybe as nice job as they did in describing in their document, kind of focused it on what these scenarios look like, but that's what I think we're trying to get at. Any questions here? Fleming.
Yeah, so thank you, Joe. I mean, I think as you described it here, that certainly made it clearer to me. When I was reading it, it was a fairly abstract session for me. Like, I wasn't clear about what the context service was. I think you verbally provided some more description that would be helpful to put in the document. When I was reading it initially, I also thought to myself, maybe having a more concrete example in there along the lines of what you were just describing could be helpful as well. Another general question for you, and maybe that applied more actually to the previous section, but it's a general question for this document. From an architecture point of view, the things you're describing, sometimes they seem fairly broad. Is the intent that we are going to be very constrained and only describe things that apply to the WIMSE scope? Or are we trying to be a little bit broader than that because we don't necessarily know exactly what the details are of everything that we want to do at this point?
That's a good question. I mean, we obviously are scoped to the WIMSE work, right? And so we don't want to get too far away from that, but WIMSE is being applied inside of a larger system with many different solutions that it's going to have to interoperate with. So there's going to need to be some interaction between that. And so, like, I see, interaction with how, let's go and call it transaction tokens, and maybe that's what we should do in the document. Let's call it that. That interaction is an important part of the architecture of an application, and something that we would need to understand in order to know how, in order to make security assessments of it and other, types of analysis. But I don't know that I have a clear, this is the line that we would draw. I think we need to work through that as a group to figure out what's the appropriate.
Yeah, and it will probably evolve over time as well, right? As we get more details. Okay, makes sense. Yep, thanks.
Yeah. Peter?
Chair hat off. So I was wondering, Joe, to get your thoughts on this context service. Do you envision that as something, or do you think of that as something bigger than the transaction token service? Or do you think of or maybe the transaction token service is an example of a context service? But I'm kind of curious to get your thoughts on whether you envision that to be a concept that's bigger than transaction token service. A little bit to your previous point around like how you might want to reference this in the text as well.
So, I mean, today I don't have a transaction token service because I don't know anything about transaction tokens, right? But I do have a service that, goes in and translates from an access token to an internal JWT that gets passed around internally. And so, like, my answer here is that I think it's a more general concept, right? But I think, and I need to, think a bit more about transaction tokens, but I think transaction tokens actually encapsulate that concept very well. So, like, it's a general thing, but like transaction tokens could be the model instance of that, and you could have something different than transaction tokens that fulfills the same purpose because you've done something proprietary. I don't know if we need to make that differentiation in the draft, or we could just say it's transaction tokens and that's it. That's why it's this context service, because I was trying to generalize it to see if are there other things besides transaction tokens that people want to include.
No, that makes sense. So I think that approach of maybe describing this idea of the context service and then explicitly referencing the transaction token service or transaction tokens or transaction token service as defined in the transaction token specification as an example of it, right? Like that could be sort of a way where you can make it very concrete for people, but then there's also, that's, as you maybe we'll learn something, or there is some other kind of context service that needs to be defined in the future. So that makes sense.
Yeah. Thanks. Honest.
Yeah, I think it makes sense to consider the architecture as a little bit a broader description where we also work on some of the edges which are currently not in scope of the current work, because the scope also changes, and for the reader to understand the bigger picture, I think that's important. Helps.
Yeah, and I think the concept of context is a bit squishy as well, and something that we want to kind of define and convey in the architecture as a thing, and probably needs a bit of work. The other thing is I after going back through this section and some comments people have made, it's, we could have done a better job in this section of saying, hey, transaction tokens are an example of this. There's a couple places where we allude to it in kind of a very obtuse way, but like really that's an example, a concrete example that we can point to and say this is what we mean. Andrew?
Yeah, just along the lines of this context service, I don't know if this is kind of what you had in mind with this, but what I thought as I was looking through this document, in addition to the transaction token type stuff you're talking about, is this seems like the type of place where you could do something like a posture assessment type of situation.
Yeah, and I think that would be a good question also for people in confidential computing and other places. Is there a way that we can put that sort of thing into the architecture as a context service, right? Which is kind of this generic sort of component that lets you augment this context that's getting passed around between different workloads. And like this is a very simple interaction here, but certainly like this service could be contacted at multiple points within the process. But we always need to be kind of conscious that when we do that, we kind of introduce latencies and things like that into the whole transaction.
Yeah,
But yeah,
totally.
I think that there is reason to keep it. And what I'm hearing is there's reason to keep this as a general concept. We probably want to go and be specific that, hey, this transaction token is an example that we want to work with, and we should. And yes, there are these other examples of like how we want to do posture assessment and other types of attestations. But there may be some services that are out of scope of a context service. You know, potentially if we're trying to do some auditing or something like that, maybe that's not. I think that's something we need to explore.
Awesome. Thanks. Makes sense.
Joseph.
Yeah, hi. So I'm just for a little bit of context for myself. Is the context service kind of overarching on top of the transactions? Do you see that? So the transaction tokens would be something that would have a life, and where the context service could be not transcend, but it would be something that would live beyond the transaction. Obviously, transaction tokens have some lifespan that, you know, either it's the workflow that's executed or the client return that it ends its life, but the context could live on.
Yes. So that's a good question. So in general, the context token, if it's a transaction token, is kind of meant to last for that particular transaction, right? And so it's got a lifetime. That lifetime should roughly correlate with the transaction. It won't exactly. Now that token may be of use, say, post that after it expires or after that transaction's done, that token could be of use in some auditing process. So it's still valid at that point. There's also an area which we haven't really gotten into very deeply yet, which is how, if at some point in this workload process, we're kicking off some asynchronous process that may take some time. What is that going to look like? Do we need specific constructs within this environment to kind of deal with that? And to that, I think some of the things can be dealt with the exact same things that we have today, or that we, with the context token or with the transaction token. But maybe some of the other things for long-lived processes or things that become a scheduled batch job or something like, there's different things that we can have. They may need some different considerations, some mechanisms for impersonation or mechanisms for, establishing a context in a different way, because the original transaction has quote unquote expired, right? So I don't know if that's what you were getting at, but
yeah, I'm getting like AI agents, things like that, agents that are autonomous and are asynchronous. Yes.
Right. So I think that's a scenario. That's one of the ones we need to tackle once we're kind of think we're going in a good direction with these things, is kind of that, what do we do with something that's not necessarily triggered from this application client, but is triggered in some other way.
Right. Thank you.
All right. So I think, this has been good. I think there's a number of things for us to go back and think about. But I will move on to the next one unless anybody has any parting thoughts. All right, thank you. Let's go to the next one. Okay, cross domain. All right, this is a little bit more complicated, and this is also maybe a little bit more incomplete than some of the other ones. they're all really incomplete, but this is perhaps got a few more moving parts. So in this case, it's fairly common, and I've kind of lumped two scenarios in here that maybe this should be broken up into multiple things. But your application client's making a request, it gets a context token or whatever happens, translation at the gateway. Now, it's very common within your application infrastructure for your workloads to need to talk to things that are external from maybe your trust boundary or in a slightly different trust boundary, such as maybe some cloud infrastructure, right? And reason why this is maybe a different trust boundary is you might need a different type of credential to talk to that, or maybe you can use the same credentials that you have. But in any case, you're going to need to make external calls. In some cases, you're going to need to talk to a token service. We call this a token service. Is it different than a context service? I think so, because you're getting an access token essentially to talk to the external service. May there also be a context token? Perhaps. Like, and these are things I think we're going to have to work through. But in workload 1, we're saying, hey, it can talk to this external infrastructure using its workload identity credentials, because that's the way the thing has been set up, right? Is that realistic? Not sure. Workload 2, in this case, workload 2 is going to have to get some kind of credential that it can a token that it can use to talk externally. And this could be within its internal trust domain. And this could be for several reasons. One is it doesn't want to disclose the information that is about the internal environment, and it needs to translate that into something that's acceptable externally. It could be that the token format needs to change. It could be that additional information needs to be included within that token to make it work externally. So that's what's happening in this 5 and 6 in this diagram. It would also be equally valid to say, hey, there needs to be a token service external to the system that the workload needs to talk to in order to get a token to talk to the external service. So I didn't to describe that here because I kind of ran out of momentum, but there could be a token service in this outside of the trust boundary that gets involved. The other sort of complication here is there is kind of a change across domain workload identity draft in OAuth that I'm a bit behind on, that I think discusses a lot of these issues, but that I think will align with this somewhat, but I haven't quite been able to get through it and make it through that analysis yet.
Yeah, hi, this is Kelly Bergen, the authors of the identity chaining draft, and I do see a lot of applications in what you've just been talking about.
Yeah, I mean, I think it's the use case is very similar. Like it's the same use case, right? Now the goals of what that draft is, I think there are some slightly different goals, perhaps, than what is in this architecture, at least in this scenario. But maybe there is, maybe there isn't. I need to go in and look at it a bit more, and certainly any kind of feedback that you have on applicability or whatever would be helpful. Michael has been patient.
So just I'm a little bit two confusions. One is there any relevance to this arc in the corner of the squares, or that's just a AASVG thing?
Yeah, I just saw that now, and I don't know where that came from.
Okay, all right. So it's no semantic content in there. That all right. So that's the first part.
Right.
So I want to be clear. So that token service that ARC5C goes to, that's producing an access token for ARC6, so workload 2 can access that external service.
Yes.
Okay. So, I just find that really bizarre to me that the authorization token for this external service is within the trust boundary.
Yeah.
Do you want to explain to them more, or maybe give me an example of why that is? Like, why isn't it somewhere else, I guess?
So I think the answer here is that this is the case where you would have both. Okay, so there would be an internal token service that sort of that neutralizes that token or creates the right type of token that you can present to an external token service that would then give you the token to then access the external service. I think that would be the way it would happen most of the time. However, right, there are things that I see in effect today where somebody has a token that they use internally. Okay, say a Kubernetes service account token that I've retrieved from somewhere, and then I configure some external service to use that Kubernetes service account token to accept that. Right now, there's a number of problems with that particular methodology, in that, like, you're sending an internal token to an external service. So I think it is something that's done today. Whether it's the best model is a good question.
Is there a back and forth? So could I think of this token service as encapsulating a credential to the external service, such that Workload 2 never has to see the private parts of that? But is there potentially then a challenge response portion that we're just not seeing in this 5.6 interaction?
I'd say probably in a challenge response in like kind of a round trip between workload.
External service says here's a nonce to Workload 2. Yeah. Workload 2 passes it to the token service, gets it signed to prove freshness, for instance, and comes back and says, here, I've complied to your freshness requirements or whatever.
So I would say typically no, right? Okay. Typically, like that's not a thing in these transactions. Like providing a nonce, signing it, and sending it back is usually a round trip that is avoided for performance and convenience reasons. Now, would things be better with that? In my opinion, sometimes yes, but like that's not the way they work.
Well, there are other ways of getting freshness, like the token could have a clock in it or other stuff like that.
Tokens usually have an expiration and an issuance date and those sorts of things that you can use for that, which it solves like 85% of the problems. And then you have things where like, well, I could have generated a bunch of these things and stored them and whatever. But yeah, Fleming.
You brought this up pretty much already yourself, Joe, but just wanted to reemphasize that the distinction between the token service and the context service, I think we have to be pretty clear about that. So totally agree with the scenario here. This is different, but there seems to be some overlap when you describe functionality. I don't think it's the token exchange that's necessarily the core piece here, right? It's the across domain. That's really the core piece here.
Yeah, and I think that needs to be clarified as well, right? The issues that have been brought up as like, well, where does this token service actually live is like, that's a fundamental piece that I don't think that I haven't really, I'm sure people on this call have thought through pretty well, but like in this particular diagram hasn't. So.
Okay, thanks.
Peter.
Similar comment as before. I wonder, it might be interesting to look at the identity chaining draft and possibly reuse some of the language, right, for consistency. And then I think the other thing, maybe likewise to the transaction token discussion earlier in the context service, one option is to also say, and an example of this is the identity chaining draft, which is very specific to maybe OAuth in many ways, and that may leave some scope for other kinds of cross-domain type access approaches as well.
Yeah, but it gives us something concrete also, though, even though it's one example, it gives us an example to kind of make sure that we're like on the right planet, you know. So yeah. Thank you. All right, so this is the last scenario that we have prepared. I think what Yaroslav was going to give us talk a little bit about the gateway, because the gateway is also something that we've slipped in there that is not necessarily the simplest concept either.
Thank you, Joe. So we have about 10 minutes remaining, and we have one more section after this one, which I believe is much more important. So I'll really skim through key points here. Now, yes, in the WIMSE architecture, we introduced a relatively new concept of identity gateway or gateway service. I think we also refer to it as identity proxy in some parts. So we certainly need to be more consistent when it comes to terminology. So idea of gateway service is it's an entity, could be a workload, could be a service from your public cloud provider or hypervisor or whatever, that is providing more than traffic routing, that can tinker, so to speak, with identity. So it can have one of those 3 or 4 properties outlined here. It can perform translation between trust domains. So if you have 2 different trust domains using separate language or requiring some kind of context translation, then a gateway is specifically tasked with that role. Establishing and propagating security context, so additional security context on top of what workloads themselves are providing. So hopefully that will address some of confidential computing use cases when we have certain additional context information that would be specific to workloads, but not necessarily should be reflected in WIMSE identity. Access control, so basic filtering, making sure that only requesters who are authorized to access something can get through and reach those precious workloads. And then routing to workloads depending on the request path and identity, basically work that quite often performed by load balancers or outbound gateways, other things in existing quite common data center networking stack, but that needs to be identity aware when it comes to WIMSE. I'm glad there is nobody in the queue, so we can save a little bit of time here. So my ask to the group is, again, it's a relatively novel concept. Please take a look at the wording and raise any issues where you think we could improve the definition and properties of the gateway service. And with that, I would like to hand it over to Hannes.
Okay. Thanks, Jaroslav. So this is mostly text that is only available on a slide and it's not in a document, unfortunately, yet. We want to sort of like, we had discussions among the authors, but would like to get a feedback from the group to begin with. So where does this remote attestation fit in? And this is the figure you see here is from the Workload Identity Practices document. And there in the sort of the lower part of the figure shows the platform. And platform, the workload platform, is more than obviously the host and the workload itself, but it's actually the interaction which happens with, so to speak, the control plane, which is here the box is labeled as credential issued by platform. And often the workload itself, when it starts, it's like it doesn't have any credentials. It's basically just a generic piece of software, and it needs to talk to that credential issuing platform to get the credentials in different forms, and thereby in that request, the platform wants to make sure that the workload itself or the environment it runs on is actually has been verified. It hasn't been modified. It's a trustworthy platform, so that in the end, only legitimate workloads running on sort of identified or verified hosts actually given and issued the credentials, which is sort of the step, which is only sort of very abstractly highlighted here in step 1. And once that information, the credential, has been issued in form of an X509 certificate or maybe an OAuth token in some form, it can then turn around and talk to the authorization server. And here, this is the step 2, the present assertion. So this credential that is being issued is sort of transforms, at least in that document that is being referenced here, terminology-wise, transforms into an assertion, because there's some assertion grants and other language that is used in OAuth that is being reused here. And so we've been looking at the different ways on how this is done. So there's some text in that document that was formerly the BCP document on how the workload actually gets that information. And there are different techniques used in practice today, from environmental variables to files to domain sockets and the like. So there are different techniques. If we go to the next slide, but there's what is the interesting aspect from an architectural point of view is something that I'm going to show you next. Joe, can you switch over to the next slide? Yeah. Is that, yeah. And only one slide, not, you went to this one. Yeah. So this is one model that is used here. 1 second. So it basically, I zoom in here with this diagram into that interaction between what I now call the credential issuer and the host in which the workload runs in. So there are multiple workloads in that. Sort of the boxes are supposed to indicate that. And one way to deal with this interaction between the workload getting this credential and being started with that credential involves an agent. So that's what some of the technologies do. And when attestation, remote attestation is used, there is something, there's a whole universe of terminology from the RATS working group, but in a sort of, in a nutshell, there's some information that comes from the lower layers, software, hardware combination, which I label here evidence. See the RATS terminology for all the details. And the agent basically relays this information when it requests these credentials. It provides that to the credential issuer, which then in turn may consult with other entities in the backend to verify this attestation evidence and apply policies and so on to decide whether this is good enough for interacting and starting the workloads and issuing the credentials to them. But when it has done so, it issues the credential as before. The agent relays the credential to the workload using one of the previously mentioned mechanisms, and then the whole then starts as Joe mentioned. But then there's another model which we can also see being used in industry is, and if you go to the next slide, you can see that that's sort of more the confidential container approach, which sort of like subsumes the whole this agent notion into the workload. Maybe I should have just encapsulated as a tiny little shim layer. So there's obviously some software running inside the workload, which is the confidential container, but it again needs to obtain the remote attestation information, the evidence from the lower layers. Details differ between the different technologies, but then the workload interacts with the credential issuer in the same way we've seen before. It attaches this evidence. The remote attestation information is verified somehow by the credential issuer or some party it interacts with in the backend, and then it issues the credential to the workload, and it can then interact and then potentially download some further configuration information and so on and so on and so on, or gets more information than just the credential to get the job done. So those are two sort of usage models we've seen, and we were wondering whether it's useful to describe them in the document as sort of like the bigger picture, without going into the details, but just providing pointers to solutions and terminology there.
All right.
So that's,
Thank you, Hannes. Sorry to cut you off, but we are at the end of time for the interim meeting. The slides will be available. I encourage the authors to drop any additional notes on the list for anything we weren't able to cover today. And the notes will be available along with the recording, and I think we get a transcript as well. Please continue the discussions in GitHub and on the list. And our next scheduled meeting is in Bangkok at IETF 122. I think it's 122. But hopefully we'll see a bunch of you all there, and look forward to the continued progress on all of this work in the meantime. Thank you all for coming today, and thank you especially to our architecture draft authors for providing all of this information. Peter, any last thoughts before we go?
Well, thanks, Joe. Thanks everybody for your contributions and the lively discussion. Mark, I dropped the GitHub link in the chat, so you can follow it there. It's also in the meeting materials, so you can find it there as well. Thank you, everybody, and see you in Bangkok.
All right. Bye all.
Bye-bye.
thank you all.